Hey guys, welcome to part 2 of the section 5.1 notes. So as you can see here on the screen, we've done a number of factoring equations or solved by factoring equations already. So you can eyeball those up if you want. Number 1, that's kind of a big deal because it had a GCF. 2, 3, 4, and 5 did not. They all had 2 sets of parentheses. And the reason I mentioned number 1 is because here's where we left off on number 6, and it's going to have a GCF. Now, for starters, we got to have 0 on the end of these guys. So the first thing I got to do is I got to move that 18 over so that I have nothing on the end or I have 0 on the end. Then I can do some factoring. So does this guy have a GCF? And the answer is yes. You always want to try that first. So do not jump straight to 2 sets of parentheses. Check it out. What number goes into both of those? 2 does. Do they both have ends? No. So GCF first. All right, 2 times 4 would give me the 8. Never messed with the n squared. 2 times 9 will give me the 18. Now, let's see here. Oops, I screwed up a sign here. To move the positive 18, I was thinking he was negative 18. Sorry about that. Grab the eraser. So that guy should have been a negative right there. Yes, even math teachers make mistakes. So if you picked that out, good for you. All right, to continue. So I always want to factor until there's no more factoring to do. So the fact that that 4n squared has an n squared in it should kind of give you heads up that it could factor or should factor. So how do we get 4n squared? Well, how about 2n times 2n? And how do we get 9? Definitely 3 times 3. And how do we get negative 9? It would be 1 plus and 1 minus. And there we go. So that's the factoring. So again, the factoring is not the solution. The solution is to keep going and tell me what n equals. So if this shortcut does not make sense to you, feel free to look over there at number 5, and better yet, run the part 1 video. But what we're going to do is we're going to say this. In fact, let me jump up to number 2 just to illustrate one more time. So in number 2, there's only one number in the set of parentheses. So the shortcut is just to switch the sign. I go from negative 7 to positive 7. In this second set of parentheses, there is only one number. There's a 4. And I switch the sign to go negative 4, and that's the answer. But if you look at the 2 parentheses we've created down here, there's 2 numbers in each one. So again, if you don't like this shortcut, please check out the previous video, and I'll show you how to do it the long way. But the shortcut is to do this. So if normally without the 2 there, we would have said the answer was negative 3, switch the sign. You just make a fraction out of it. So negative 3 over 2. So if the 2 wasn't there in the second set of parentheses, I would switch the sign, and I would say the answer was positive 3. But since there is 2 numbers in there, I just make a fraction out of it. So there's the shortcut. Now, you might be asking yourself, what the heck's the deal with the GCF, the 2 that's out in front? So go clear back up there to number 1. In number 1, sorry about that, number 1, we had a GCF of 3x. But I said 3x. In other words, there was a variable there. So see the variable right there? So if the goal is to solve for x, then I want to know an answer that goes with that x. But if you look back down here on number 6, this GCF of 2 does not have an n. So how could I plug a number in there to check it, or how do I solve for an n that doesn't exist? I don't. So while it was helpful, we needed it to come up with the answers, it doesn't. I don't need it at the end here when I come up with my answers for n. So here's an n. I need an answer. Here's an n. I need an answer. That 2 out front has no n. Don't need an answer. And quadratic equations have 2 answers. So there we go. All right. So we're going to segue into something a little different here. This is the other aspect to work at, coincidences in math. So what we're going to do here is we're going to solve this equation that's given, just like we did the other ones up above. So in other words, you factor it. When in doubt, factor it out. So if I'm going to get an x squared and I need an x and an x, the only way to get 3 is 3 times 1. I need a negative 3, which means one's got to be negative, one's got to be positive. I'll let you check the outside inside, but I'm going to tell you it's right. And if I were to switch the signs to solve, like we talked about, the shortcut, and if you didn't watch video number 1, here's why. What's negative 3 plus 3? That equals 0. That's what I want. So I switch the sign on the other set of parentheses, I get positive 1. And again, what's 1 and negative 1 make? It makes 0. So switch the signs. That's the shortcut. So what's the coincidence between the graph and the answers I just wrote down? Eyeball it up. Hopefully you will notice the graph crosses the x-axis at negative 3. And pardon me for my attempt at making it cross at 1. It missed by a little tiny bit, but let's take my word for it when I say it crosses at 1. So not a coincidence. The answers to a quadratic equation are also the x-intercepts for the graph. And that is an important detail which we will talk about on down the line. So why do you need to know that? Well, here's why. We're going to make you go backwards. We're going to give you the answers or give you the graph or give you the x-intercepts, and we're going to say, hey, come up with the equation. So I would hope, based on what we just said a second ago, you would know that those are the two most important spots on the graph. So I know that positive 1 is an answer, and I know that positive 4 is an answer. So the question is, how do you get the equation? Well, let me scroll back up for a second. Check this out. If we knew the answers, which are right here, which we just came up with in that drawing down below, then that must have been the parentheses with the signs changed, and that must have been the equation that went with it. So what we're going to do is reverse the process. So if I know the answers are 1 and 4, then I know the parentheses or the factoring that went with this problem would have been an opposite sign and an opposite sign. Well, the question would be, how do you make two sets of parentheses go backwards and look like this guy up there? Well, how about a FOIL problem? Remember doing those? The FOIL problems were pretty easy. Now, some of you were using a box to multiply these out with, and you're welcome to do that. I'm not going to bother. So I'm going to go first times first. I'm going to multiply the outside 2. I'm going to multiply the inside 2. And I'll multiply the last one times the last one. And then I'm going to combine those guys. So the equation in standard form, well, let's see. Standard form means it just looks like this. There's a squared term. I'm going to add up those x's for a total of 5x. So there's a linear term, that guy's called. And there's a constant term. So that's standard form for quadratic. Now, the only thing it's missing is this word right here. And this is really important, and I hate to be picky, but what's missing if it's supposed to be an equation? An equal sign. And what was on the end of all the equations? 0. And by the way, that's why another name for x-intercepts over here is called zeros. So really, that's not that bad if you think about it. All right, I got time for, I think, these first two, and then we'll catch bonus round in video number 3. So all you have to do is write two sets of parentheses where you switch the signs. So we're just going backwards. So if that was positive 9, I go with a minus 9. If that was negative 3, I go with positive 3. It wouldn't hurt to write the equal 0 down now before you forget. Foil that out, box that out if you want. Okay, I'm going to shortcut here because I'm getting a little low on time. The inside would be negative 9. The outside would be positive 3. And if you combine those, you get negative 6. Last one times last one is 27. Negative 27. Equals 0, and we're done. So no big deal. Now, 2 is a little tricky, and here's the reason. If you recall, earlier in the video, if you get 0 for an answer, that means you did a GCF. So I would hope at the very least you would know, or it would make sense, that you're going to need an x minus 6 for that 6. So here's the beauty of a GCF. A GCF means there was just an x out front, a little solo x. Now, you could actually make that 3x, 5x, negative 2x, any x you want, just as long as you have an x. So there's multiple answers for this. And then that just becomes the distributive property. So if I times these guys out, I get x squared. Times these guys out, I get a minus 6x. This one does not have a constant term. In other words, there's not a number without the x. But I stick the equal 0 in the end, and I got it. So really, the GCFs are even easier. All right, you want to check out the bonus round, and I would check out part 3 video. Thanks.